The broadcast is now starting. All attendees are in listen-only mode.
Hi there, my name's Francis Vigent. I'm CEO here at KnowAtom, and I also am a former STEM educator myself. I spent about 10 years in the classroom grading students and was fortunate enough to have one of the highest achieving elementary school classrooms when I was a teacher in the country, actually. So going into this, I apologize I can't be there in person, but what I'd like to do is just kind of lay out a little bit of who we are and how we're different than other solutions you may be looking at, and what I think makes us really unique in terms of our effectiveness, because we have quite a bit of data that backs up not only the research behind what we do, but in particular the impact that it has on children, whether they're English language learners or general ed, you name it. So a bit of who we are. KnowAtom is a group of educators. We have been in the STEM space, developing curriculum, providing materials and professional development since 2006. Our products are used all over the world, mainly in the United States, but like I said, all over the world. When we talk about a complete K-8 solution, what we mean is NGSS design curriculum, targeted professional learning, and I differentiate a little bit here around professional development and professional learning purely because we are not training teachers to use a magic phrase. What we're doing is we are helping teachers to understand not only the resources that they have, but the pedagogy around how to deliver those resources most effectively as teachers are shifting their practices from what may be a traditional model to a next generation model, and really focusing on that inquiry environment. The third piece is integrated hands-on materials. Every lesson or unit, every unit that consists of lessons in our curriculum, there's a scope and sequence and so on. Each of those units is hands-on. Children are developing and using their ideas. They're solving problems and questions that they have around phenomena hands-on. Okay, so what KnowAtom does is provide those materials so that as you go unit to unit, you have exactly what you need, whether it's consumable or durable. And of course, all of this functions to support that phenomena-driven learning environment where children can work in small groups and, again, discover for themselves whether there's evidence to support their thinking or not, or if there's evidence to support their prototype solution or not. Okay. The particular model of KnowAtom is something called integrated, which you are probably all familiar with. But an integrated approach, to sort of sum up briefly, is taking earth science, life science, physical science, engineering, in the nature of science and engineering, and what it's doing is it's making that a part of every school year, kindergarten through 8th grade. What you'll notice here is that our kindergarten curriculum has 3 units, but these are larger units. This follows a model in terms of the length and complexity of units that you would traditionally see in a lot of other programs. 1 unit in this case would span 3 months. This has to do a lot with what standards are at the kindergarten level. And basically, these are the core, focuses of kindergarten. But once you leave kindergarten and get into 1st grade on up, there are 9 units. That has to do with the standards that are intended for mastery by the end of each of those grades. But it also has to do with KnowAtom's model that follows the peak alignment criteria, as well as EQUIP rubrics guidelines, where students are learning standards and clusters. And so each unit is a month-long experience, or it's a month-long experience that consists of week-long lessons. Okay, I won't get into all the details of what that means, except to say that it doesn't assume that you're teaching science every day. What it means is that the science time on learning that you do have available and there are guidelines for what that should be from the states, and would be happy to share that. But the key here is that a lesson is a group of experiences that take place over multiple days that starts with phenomena, accessing that phenomena through visuals, reading, video clips, that sort of thing, moves into scientific discourse, or what many of us would call Socratic dialogue. And through that process, children are bringing up their wonders and then moving on from those wonders to the problems or questions that they wonder about but have no evidence or data to support what they think may be the solution or answer. So that's where students learn and actually plan. They learn how to plan an experiment or prototype, and they develop that as a skill set, and then use their plans hands-on to gather the data, form an evidence-based conclusion. And then, of course, in that debrief and transition, what's happening is that children are comparing results between groups, sort of a thought-intensive gallery walk, in a sense. So, again, would be happy to go into any of this more in detail if you'd like, but this integrated model flows all the way from kindergarten through 8th grade, which you see here, the middle school. And what's happening is an intentional nurturing and scaffolding process, okay? These units are ordered in such a way that children are progressing through skills and content and changing frames of reference and those cross-cutting concepts so that they're getting an opportunity to encounter that phenomena, not only hands-on, but to build a network of concepts or a framework of understanding and refine that framework over the course of multiple units, and also having the opportunity to develop those skills and practice them, those science and engineering practices. So the curriculum is available in print, and everything that's in print is also available electronically. So what you kind of see in the background here is KnowAtom's Interactive. Each teacher gets a username and password. Within that is all visuals, teacher units, student readers, if there are any templates or videos, and all kinds of stuff like this. We also have a tool within this called Soccer Circle. What that is it's an electronic tool for holding Socratic dialogue in a virtual forum. It's sort of a cross between a group text and a private chat room, which is moderated by the teacher. We found this to be very effective in inner circle, outer circle models of Socratic dialogue, getting students who are English language learners, as well as students who may be a little shy when it comes to sharing verbally. So that's a part of this. If you are using a learning management system, let's say Google Classroom or Schoology, all of these resources can be transferred and used in those learning management systems. And so we're platform agnostic, but we're also compatible with your learning management system versus trying to add another layer in there. Moving forward just a little bit, the way, and really our focus here with students, I think something that's a real differentiator for us is that our focus is on critical thinking skills. What do those look like in a granular sense? I would go beyond saying creating, evaluating, and analyzing to say learning thinking moves, learning those science and engineering practices that are required in order to engage in the discipline of science or engineering, to actually develop and use that content. So the way we go about that and all these resources that we are providing as part of this cohesive and curated solution, what happens here is that children are learning by being scientists and engineers hands-on on an everyday basis. So students are coming up with questions. They are then planning their own experiments. They're using those experiments to gather new knowledge to them, hands-on. And then as they're progressing through these lessons, they are using that knowledge to identify problems and to solve those problems hands-on through prototyping and testing those prototypes, gathering evidence for whether the proposed technology that they've envisioned actually solves that problem. And there's ELA and math Common Core skills, as well as standards that are really being hit here. We document those in all the lessons as well. So, again, we are not a math or ELA program. However, by being, I think, one of the most, if not the most, authentic, hands-on K-8 solutions commercially available, we are giving students an opportunity to use those ELA and math skills in the context of science, and vice versa, to carry their thinking moves and their science and engineering practices and their Socratic dialogue or scientific discourse techniques, which they're learning through the program, forward into other disciplines as well. That's common feedback that we hear, that students do actually carry that forward. So the kind of setting that you can use this curriculum in is any setting. We designed this to be able to function in large urban districts as well as very rural schools with multi-age, multi-grade settings. Of course, we don't, in a public school, large urban setting, we're dealing with most often, K to 8, and that's the way we're designed. The importance of understanding that we can operate in these different types of settings is that you don't have to have special equipment. We're providing everything as part of this, durables, consumables, the professional development, and so on. And whether you have a multi-purpose room, a classroom with tables, a classroom with desks, a special science lab, whatever, these resources can be used in any of those settings. So when you take a look at this particular image, this is some 5th grade students, and they're working in a multi-purpose room that also functions as their lunchroom. No big deal. When I talk about phenomena-driven learning, I want to explain what I mean by that, because I think that this is also a key differentiator for KnowAtom. The way that phenomena drives teaching and learning in KnowAtom is that we have a kind of anchor phenomena, a large, complex, real-life thing. Think of it as a scenario or an image or something, hurricane, which we cannot replicate in the classroom. But what we can do is we can look at it, we can form opinions about what's happening and why it's happening. And as individual students and as a group, we can wonder about aspects of this phenomena, discuss it. And in some cases, we're going to have knowledge in our group which is able to answer some of those wonders. However, again, as a whole class, there are going to be things which we wonder but have no answers for, no evidence to support what we think is the reason. And so that leads us to either problems or questions, which we can use an experiment or a prototype to actually experience whether what we think is the answer to that question or what we think is the solution to that problem hands-on. So using scientific or engineering process, students learn to create plans. They then use those plans, which are, we go through this in professional development, but all of this functions as a formative assessment, multiple formative assessments. So students go through formative assessment checkpoints with their teacher using that scientific or engineering process to develop their own plan. And once they have a plan, they use the materials hands-on to actually carry out that plan, get evidence, and then they use that evidence, they analyze it, and they create an evidence-based conclusion around whether or not the prototype or the hypothesis that they had envisioned was supported or not supported by that evidence. This question or problem that students are diving into here is a thread of that anchor phenomena. So what's important here is that the debrief and sort of gallery walk and students arguing from their evidence as a group in their approach is also an opportunity for what we would call the investigative phenomena, that experience that they had hands-on in their investigation, to inform and provide a basis for reflection on that larger anchor phenomena. Okay. I mentioned earlier about hands-on materials. Just to give you a quick run through, what we mean by things like durables are things like multimeters, things that are not destroyed or consumed by virtue of using them in the classroom. Consumables would be things like, the tin foil, paper clips, maybe batteries, some of these other elements which are going to be used up, destroyed, modified as part of prototyping or experimenting in a way that can't be undone or is unlikely to survive from one year to the next. So an example of that would be something like sand, which we can use in our classroom. Let's say we're doing something with tectonic plates and so on. Theoretically, we can reuse that sand next year. However, in reality, and again, as a group of teachers developing curriculum, we understand that there's a good portion of that sand that's going to end up on the floor, on people's hands, and so on. We want, and we set this up so that teachers can teach with integrity from one year to the next, so long as they have access to the materials. And we even guarantee those materials while under contract. If a student breaks a multimeter or such thing, we will replace that free of charge if it's returned to us by the teacher. Of course, sort of willful destruction, loss, theft, people running over things with the bus, that sort of thing isn't covered. Quick thing to mention is that the student readers are provided in a consumable print format. Any activity sheets, all the vocab lists, things like that are in there. The reason, though, that we provide them as consumables isn't only so that students can write in an activity sheet. The reason we provide them as consumables has to do with students being able to use their close reading strategies and apply those in their science reading. Again, this is a group of students working on the floor with a prototype. Key thing I want to mention here is that our curriculum is designed for groups of 2. Some communities do opt for budgetary reasons to do groups of 4. We've seen high levels of effectiveness in both approaches. However, groups of 2 has a lot of advantages, and we think is a better way to go. What I want to point out here, though, is that these children have developed a prototype which is different than all the other prototypes in their classroom. Again, it's their idea. They're learning how to develop a solution to a problem that they are seeing. Just a quick mention on that professional learning. So the way our professional learning works is that with a new implementation, we work with communities to work in grade-specific or semi-grade specific, like grade band groups. We work with your team in person, particularly the full day up front, to go through resources, pedagogy, best practices, answer questions, and help folks work through some videos, help folks envision how they are going to approach this curriculum in their classroom. And then what we do is we work with the district to find 2 to 3 check-ins where we, again, work with teachers and administrators, if they wish, to go on learning walks and engage in grade-specific classroom coaching, not in an evaluative capacity of a practitioner, but really thinking and looking from a student's perspective about how we can tweak practices to increase engagement and really learning is what we're talking about here. Because from our perspective, learning is when a child who is learned is when a child is able to develop a problem develop a solution to a problem or an answer to a question such that they can gather the necessary evidence independently for themselves in order to inform their understanding, modify their beliefs, or remove doubt in a sense. And so these are skills that, again, are useful in any college or career choice or discipline of interest. So we help, again, when it comes to professional learning, professional development, there's not a one-size-fits-all. We don't have a module per se that we go in and we try to deliver to a group. We really try to meet groups where they're at. We think about this as a community of practice in which we're a partner. And we try to work with the teachers, teacher leaders, and administrators to support that community of practice in this transition to next generation style inquiry, classroom environment, the standards itself, assessments, and so on. So that's how it works. The coaching, new implementation, kickoffs, communities of practice, by and large, we do all of this in person. There are some hybrid models where we also provide some online support. And then we have within our online platform and also on our website support resources. If you visited KnowAtom.com, if you look under Learn More, down the bottom you will see tons of ebooks, webinars, blog posts. All of that's free to the public, again, regardless of what program you choose. But I would just encourage you, regardless of your student socioeconomics or location, your district size, we work with one-room schoolhouses in very rural areas with multi-age, multi-grade settings, all the way up to 200, 600 classroom districts where we're dealing with dozens and dozens of buildings and helping to bring all that together. But the thing that unites all of our customers, I would say, is that they tend to be they set high expectations of themselves and of the resources they use. They are very driven to deliver a high value, high engagement experience to their students in such a way that it is raising their level of understanding and is developing a skill set which will last well beyond their fourth or fifth or sixth or eighth grade year. So if you have any questions, please feel free to reach out. Unfortunately, we have only scratched the surface at a very high level. If you'd like to download a sample unit on Student Reader, you are welcome to do that by going to KnowAtom.com. Click curriculum. You can also look at some more details around professional development. And otherwise, feel free to reach out to me. My email address is fvigeant@KnowAtom.com. And again, I'm the CEO here. I was a co-founder of the company about 13 years ago. And you can also reach out to talk to any of our customer relationship or sales folks as well, just by going to KnowAtom.com and click on curriculum or contact us. And I just can't emphasize enough, if you do contact us, we are not here trying to sell anybody anything that's not a good fit for them. So for us, when you reach out, if you think that this may be a good solution, we'd like to get to know your needs more, and also to help you understand what we offer better. So thank you again, and I appreciate your time. Wishing you the most success in your transition to the new standards. Thank you. Bye-bye.